Welcome to the online education portals. Dear learners, today we are here for the SWAM portal on the postgraduate diploma on environmental and occupational health. Today we will go for sewage treatment methods. As we all know that India is facing water crisis. On an approximately 54% of the Indians, they are faces high to extremely high water stress. We are facing a very high stress under the water system. Wastewater generation in India, it is on an approximately 1.7 million tons of the fecal waste per day. But as per the official figure, it is on an approximate 78% of the sewage generated remains untreated, and it is disposed of in the various water systems like rivers, groundwater or lakes. These two main sources of water contaminations are sewage and industrial waste. With these both the population of India and its industrial landscape increasing at a phenomenal speed, wastewater volume is also increasing at a alarming rate. Adding to this is the shrinking of freshwater resources like rivers, wells and groundwater. So we are facing very high in terms of water. India wastewater treatment capacity, it is divided into two parts. Number 1 is class 1 and number 2 is class 2 cities. When we consider the class 1 cities, they are on an approximately 498 and their sewage generation is 35,558 million liters per day, and the installed capacity of class 1 city is 11,553 million liters per day. Whereas class 2 cities, they are almost more than 1 lakh in population and they are 410. Their sewage generation capacity is 2,696 million liters per day. Whereas the installed capacity of the class 2 cities is 233 million liters per day. When we consider both the class 1 and class 2 cities, they are on an approximate 908 and their sewage generation is 38,254 million liters per day, whereas the installed capacity is 11,786 million per day. So this is a very huge amount of the sewage generation as the data is showing us. Sewage is the wastewater generated by a community, namely the domestic wastewater which came from the bathroom, toilets, kitchens and many other sources. Second is the raw or the treated industrial wastewater which has been discharged in the sewerage system, and sometimes it comes from the rainwater and the urban runoff which may be from the industries, may be sewage, whatever it is. Second is the domestic wastewater. It is the main component of the sewage and it is often taken as a synonyms. The sewerage flow rate and the composition vary considerably from place to place depending on the economic aspects, social behavior, type and number of industries in the area. Climatic conditions are also taken under consideration. Similarly, water consumption and the type of the sewerage system, all these are the factors which comes for the sewerage flow rate. The main pollutants in the sewage are the suspended solids. Soluble organic compounds and fecal pathogenic microorganisms are also comes under the pollutants, but sewage is not just made up of human excreta and the water. Rather, it has a variety of chemicals like heavy metals, trace elements, detergents, solvents, pesticides and other unusual compounds. For example, pharmaceuticals, antibiotics and hormones which can also be detected in the sewage. Now comes to the composition of the sewage. The composition of the sewage mainly consider two components. Number 1 component is the water and the another component is solid. Water consists of 99.9, whereas solids consist of 0.01 only percent only. So it is a very small amount, but its importance is very high because it contains two types of the components. One is organic and other is inorganic. Organic component constitute 70% of part, whereas inorganic consists of 30% of the part. So when we see the organic component which is almost 70%, that consists of protein which contributes 65%, carbohydrates which consist of 25%, fats which includes 10%, whereas the inorganic components includes grids and the metals. So inorganic components have the smaller amount of the composition, that is 30%, whereas organic is of 70%. Now comes to the classification of sewage. How we will classify the sewage? Sewage mainly classified into three parts or into three types. Number 1, domestic sewage, number 2, industrial sewage, and number 3 is the storm sewage. Now we will study one by one what is domestic sewage. It is also known as sanitary sewage. Domestic sewage consists of liquid waste which originates from the urinals, latrine, bathrooms, kitchen sinks, wash basins, etc. of the residential, commercial or the institutional buildings. This sewage is generally have the very high foul because of the presence of human excreta in it. Second is the industrial sewage, or we can call it as the wastewater. This industrial sewage or the wastewater, it consists of liquid waste originating from the industrial processes of various industries such as dyeing, paper making, brewing. These are the various examples of the industries which consist of this kind of the waste, and the quality of the industrial sewage depends largely upon the type of industry and the chemicals which are used in their process waters. Sometimes they may be very foul and may require extensive treatment before being disposed of in the public sewers. The third kind of the sewage is the storm sewage. Storm sewage means water which is discharged from a surface as a result of rainfall, snow melt or the snowfall. So this is all about the classification of the sewage. Now we come to the importance of the proper wastewater treatment. What is the importance of proper wastewater treatment? Why we need to treat the wastewater? It is very important to treat the wastewater because it removes all the harmful pollutants which are present in our surroundings. Number 2, we have to protect the environment in which we are residing. Number 3, keeping the people healthy in the environment, and also to comply the regulations. So it is very important to maintain the environment by treatment of the sewage wastewater. Now what are the characteristics of this wastewater? The characteristics mainly involve the physical, chemical and the biological. The physical characteristics mainly involves color, total solids, odor, temperature, turbidity. And in case of chemical characteristics, it includes pH, gases, electrical conductivity, inorganic matter, organic matter and the oxygen demand. It involves both BOD and COD. Dissolved oxygen also come under this. Third is the biological characteristics. The biological characteristics includes the biological sewage are due to the presence of bacteria and other living microorganisms, for example algae, fungi, protozoa, etc. These two, algae and fungi, they are very active in the sewage wastewater as compared to protozoa. Now what are the strength of the sewage? The strength of the sewage mainly involves the total solids, your total dissolved solids, fixed, volatile, suspended solids and your soluble solids, settlable solids, BOD, TDC, COD. All these they have been checked in the sewage in terms of milligram per liter. For example, if we talk of the total solids, when we have the 350, it is considered 350 milligram liter, then it is considered as a weak contamination. But when its value goes to 1200, then it has been considered as a strong concentration. Similarly, for the total dissolved solids, when it is of 250 milligram per liter, then it is towards the weak side, and when it comes to 850, it comes under the strong contamination. So, in this way we have different parameters of the contamination under different considerations. When we talk of BOD, when it is 110, it is towards the weak side, but when it comes 400, it comes towards the 400 milligram per liter, then it comes to the strong side. So, strong side means it is a strongly contaminated at 20 degree centigrade. The sewage treatment, how we will treat the sewage? We have a machinery process for this to treat the waste and the waste water generated from the household, offices, restaurants, hotels, factories, municipal corporations and many more. So, in others we can say that the sewage treatment plants are generally used for the treatment of wastewater in order that they are often made fit use within the fulfillment of other purposes. Even the wastewater bringing of varied manufacturing and supplying units is not fit to be released within the environment or within the water bodies. The sewage treatment plants plays a very important or integral role in keeping the residents safe and healthy by clearing their wastewater with a combination of physical, chemical and biological treatment before discharging into the environment. Now, what are the objective of sewage treatment? We have 4 objectives for the sewage treatment. Number 1, very important objective is the removal of microorganic which may be the causes of dangerous diseases. Number 2, we have to remove the floatable and postponed particles. Number 3, to improve the quality of wastewater, to make the wastewater usable for agricultural and the aquaculture, etc. Now, the types of sewage treatment. How many types we can treat this sewage? We can treat by 3 methods. The sewage treatment can be organized or categorized by the nature of treatment process operation. Number 1 is the physical, number 2 is the chemical and number 3 is the biological. The sewage treatment, 3 methods. First one is physical treatment which involves the physical type of the treatment, and in this screens are involved. Mainly the nature of you can say instrumentation which is involved for physical treatment, that is the screen, and in this what is happening, the large suspended particles and the floating material that particularly has been separated. And in the second part of the physical treatment, we involves the grid chamber in which grids are separated, and number 3, third type of the physical treatment, we use the clarifiers. Under the clarifiers we separate the silt, sand and other barriers which are present in the sewage water. The second type of the treatment is the chemical treatment. Here we go for the chemical, and in this chemical we go for the nature of the unit which is required for this chemical treatment is the chemical reactor, and in this the chemicals they have been dissolved. Whereas the third is the biological treatment. In the biological treatment we go for the biological type of the treatment. In this we use the trickling filter, activated sludge, rotating, biological and many other kind of the you can say units are required, and in this organic, chemical and the dissolved kind of the wastewater is being cleared. Now, how many phases of the sewage treatment are there? There are many phases. Mainly we will categorize into 6. 6 phases of the sewage treatment. The first phase is the preparatory, or we can say preliminary treatment. Number 2 is the primary or the physical treatment, whose types we have studied now in the later I have told you, and the secondary is the third or the biological treatment. I have also given the treatment of the biological also, and fourth is the tertiary or the advanced treatment. Fifth is the sludge treatment, and sixth is the disinfection. Wastewater treatment process mainly involves the preliminary, primary, secondary and water recycling and disposal. In this, what we do, the raw wastewater, that is the sewage, that is to be fed for the screening, then goes to the grid, and from the grid it goes for the primary sedimentation, and after primary sedimentation, aeration, it passes to aeration tanks where aeration has been made, and from the aeration tanks it transferred to the secondary sedimentation, and from primary sedimentation to secondary sedimentation we also go for, we put all these sewage wastewater for the digester, so that the biological decomposition can be made, and from this biological decomposition we got a huge amount of the sludge which is sent for the recycling, so that can be utilized as a very good fertilizer, and the water is sent to the oceans or the sea for the discharge. So, this is the water recycling and disposal. So, in total we have in the wastewater treatment process 5 steps. Number 1 is the inflow, number 2 is the preliminary, number 3 is the primary, number 4 is the secondary, and number 5 is the water recycling and disposal. So, this is all about the wastewater treatment. Now, we will go for one by one, what is primary treatment, what is secondary and what is tertiary treatment. The primary treatment involves the physical processes that removes the non-homogenizable solids and homogenize the remaining effluent. Number 2 is the secondary treatment. It involves the biological processes that remove most of the biochemical demand for oxygen. And number 3 is the tertiary treatment. It involves the physical, biological and chemical processes to remove the nutrients like phosphorus, nitrogen and inorganic pollutants, to de-deodorize and decolorize effluent sewage water and to carry out further oxidation. Primary treatment involves the most objectionable aspect of discharging raw sewage into water courses is the floating material. The screens were the first form of wastewater treatment used by communities, and they are used today as the first step in treatment plants. As I have already discussed, which consist of series of steel bars that might be about on an approximate 2.5 centimeter apart. These are the modern treatment plant which removes the material that might damage the equipment or hinder the further treatment of the sewage. This slide is very beautiful. It shows the bar screens which are made up of the steel stands. In many plants, the second treatment of the sewage is the comminator. Comminator is the second step for the treatment. It is a circular grinder designed to grind the solids coming through the screen into pieces and on an approximately 0.3 centimeter or less in diameter it is. And a typical comminator is designed for the second treatment of the sewage wastewater. The third treatment or the third step of the sewage treatment is the removal of grit or sand from the wastewater. Grit and sand, they can damage the equipment like pumps and the flow meters and must be removed. Otherwise, the treatment cannot be done properly. The most common grit chamber is a wide place in the channel where the flow is short enough to allow the dense grit to settle out. Sand is about 2.5 times denser than most organic solids, and thus it settles very much faster than the others. So, in overall, the objective of the grit chamber is to remove the sand and grit without removing organic materials. Organic materials must be treated further in the sewage treatment plant, but separated sand may be used as fill without additional treatment. Mostly the sewage wastewater treatment plants, they have the settling tank also after the grid chamber, whose function is to settle out as much as solid material as possible, and thereby the retention time is long and turbulence is kept to a minimum time. The solid settles to the bottom of the tank and are removed through a pipe, while the clarified liquid escapes over a V-notch weir that distributes the liquid discharge equally all the way around a tank. Settling tanks are also called as the sedimentation tanks or the clarifiers. The settling tank that immediately follows screening and grit removes the called the primary clarifier. The solids that drop to the bottom of the primary clarifier are removed as the raw sludge. So, settling tank is the next treatment, and in this the objective of the primary treatment is the mainly the removal of the solids, although some of the BOD is removed as a consequence of the removal of the decomposable solids and the wastewater of the sewage, which has been described earlier with a very high characteristics. For example, BOD milligram per liter, when you are having the raw wastewater, sewage wastewater is 250 milligram per liter, but after the primary treatment it comes on an approximate 175 milligram per liter. Similarly, for the suspended solid, which are 220 milligram per liter in the raw sewage water, and after the primary treatment it went to 60 milligram per liter. And when we talk of phosphorus in the raw wastewater, it is on an approximate 8 milligram per liter, but when it has been gone through the primary treatment, it comes to 7 milligram per liter. Now come to the secondary treatment. In the secondary treatment, the sewage wastewater leaving the primary clarifier has lost much of the solid organic matter, but still it contains very high energy molecules that decompose by microbial action, creating BOD. The demand for oxygen must be reduced or as the discharge may create unacceptable condition in the receiving waters. The objective of secondary treatment is to remove BOD, whereas the objective of primary treatment is to remove solids. So, the another aspect is of activated sludge system, which includes a tank full of waste liquid from the primary clarifier and mass of microorganisms. Air is bubbled in this aeration and it provides the necessary oxygen for the survival of the aerobic organisms, and the clarified liquid escapes over a weir and may be discharged into the receiving water. The activated sludge system is mainly utilized for the secondary treatment. This activated sludge system, it depends upon the performance of the final clarifier. In this, the settling tank cannot achieve the required return sludge solids. The solids in the aeration tank will drop and the treatment efficiency will be reduced. Final clarifier acts as the settling tanks for flocculent settling and as thickeners. Their design requires a considerations of both solids loading and overflow rate. Secondary treatment of sewage wastewater usually includes a biological steps like activated sludge that removes the substantial part of the BOD and the remaining solids. Besides this, the advanced technology is also required that involves the membrane bioreactor, and membrane bioreactor involves the membranes by which treatment can be done. The last and the advanced treatment is known as tertiary treatment. In this treatment process involves the removal of nitrogen, phosphorus, suspended solid, organics, heavy metal and the dissolved solids. Here 3 steps are required. Number 1 is dechlorination and disinfection, number 2 is reverse osmosis, number 3 is ion exchange. The legal mechanism for sewage wastewater regulation in India, it has been come under the Water Act 1974, now amended in 1988, and the Water Act amended in 2003. The current status of this wastewater treatment is that only 1/3 of the India sewage wastewater is treated, whereas the other is leading to high burden of waterborne diseases. In case of the urban water, SS is very high and there is a significant gap remain across the country, and wastewater treatment remains stuck at the national average around 33%. Maximum wastewater generation, it is in the Punjab, Maharashtra, Gujarat and UP, and it potentially treat on an approximate 65 to 100% of it is of urban wastewater. And when we talk of the other states like Madhya Pradesh, Bihar, Andhra Pradesh, they have only small installed the sewage treatment plant, but treatment is very less, that is almost 50%, whereas in the several other eastern states there is no installation of the sewage treatment plant. So why it is in the news? Capacity of India sewage treatment plant, because the CPCB of the Central Pollution Control Board, in which the sewage treatment plants in India are able to treat the little more than the third of the sewage generated per day. So CPCB is a statutory organization which was constituted in September 1974. We can reuse the sewage wastewater. It has been maximum utilized in Haryana, followed by Pondicherry, Delhi and the Chandigarh. Why we are concerning towards the increased sewage generation? Because CBC has estimated that on an approximate there is an increase to over 1,20,000 MLD by 2051, and there is a gap in treatment capacity as amplified at local levels, as STPC sewage treatment plants are concentrated in larger cities and common effluent treatment plants are unevenly distributed across the states. When we talk of your economic case in the sewage treatment plant, then it involves the capital intensive and require the use of innovative technology, for example sensors, Internet of the Things, artificial intelligence that are based on the trackers, and the high upload capital requirement in machinery equipment combined with unpredictable revenue streams make this a high risk sector, deterring private sector investment. Thank you.